Hey friends, welcome to follow up. Let's have a look at problem 2718, sum of matrix after queries. This is a newly appeared problem. So in this video, we're going to explain a solution based on the strategy that we scan the queries in a reverse order and then count the sum. So here we are given an integer n and a zero index 2D array called queries. So the query element has the following form, so type and index and value. So for each query, we're going to apply one of the following changes. So if type is 0, so we're going to set the corresponding row with index being index I to be value I, overwriting any previous values. So this overwriting assumption is very important. So if the type is 1, so we do the same thing, but for columns. So we are required to return the sum of integers in the matrix after all queries are applied. So here we have two examples. So let's use example 1 to digest. So here n equals 3. These are the queries. So now let's look at these queries from start to end, right? So the first query is type 0. So we're going to change first row to be value 1s. So we get the 1, 1, 1 in the first row. And the second query is type 1. So we're going to change the second column to be value 2s. So we get 2, 2, 2 here. Notice that so the 0, 2 elements in the first row is overwritten by 2. And the third query is 0, 2, 3. In other words, it's type 0. So we're going to change the row with index 2, and all the values are changed to be 3. So we get 3, 3, 3. And notice that the bottom right corner 2 is overwritten by 3. So the last query is type 1. So we're going to change the column with index 0, and we change the values to be 4. So notice that because here we have 1 and we have 3, so these two numbers are also overwritten here. So we get 4, 4, 4. So then if you compute the sum of elements in the final state after these queries, so we get 23. So this is example 1. So before we look at the idea, so let's look at the constraints. So first, n is a decent large number, so it's bounded above by 10 to the power 4. So and the maximum element, if we consider n squared, it can be as many as 10 to the power 8, right? And secondly, the queries has a length bounded above by 5 times 10 to the power 4. This is also a decent large number. So the last 4 queries are basically consistencies and inbound assumptions. So with that said, we are ready to look at the strategy or idea. So here, the strategy we are going to use is that we scan the queries in a reverse order and count the sum. So for this kind of problem, personally, we feel that once we digest or grasp the idea, so actually for the coding, it's not very hard. It's actually sort of straightforward. So here, the reason that we look or scan the queries in a reverse order is the following. If a row index appears again in the process, if we look at from left to right, then new value will overwrite the previous values. So in other words, only the last index and the associated value play a role. Same for column. So let's use a small cooked up example to demonstrate the idea. So here we have 3 queries forming a list. And then if we look at from the reverse, then at index 2, the query is type 0. So we are going to change the first row to be value 9s. So we get a 9, 9, 9, right? So this change caused the result incremented by 9 times 3. So here, all the 3 numbers are overwritten by 9. So this is for index 2. Then for index 1, so we have type 1. So we're going to change column with index 2. And we change all the values to be 100. But you know, this query is appears behind. So the 9 actually is not it's settled. We do not need to change, right? When we look at the previous queries. So we change the element in the second row, the last column, and the third row, the last column by 100. So this query actually caused the result incremented by 3 minus 1 times 100. So here 1 is the one already settled because the first row is already settled by looking at a query behind, right? So overall, if you compute the result, it's going to be 227, right? So we are going to code this strategy, right? So to carry out this strategy, so we're going to use set to monitor which rows or columns have already been set, and then we consider the increment during the process. So with that done, let's look at the coding part. For the ease of writing, so I have changed the query's name to be just a capital Q, right? So first, let's get the length of this queries. So there are m queries, right? So I'm going to introduce some variables. So the rows thin and the columns thin. So the number of thin rows, number of thin columns initially to be 0, 0, right? And also the result, we're going to set it to be 0. So the final state of this result is what we want to return. So in order to check if a corresponding column or row is already settled, so we're going to introduce this set, that is thin rows and thin columns, as to be two empty sets. So this is in parallel with these two variables. So we can actually organize it like this. So we put these two lines together, indicating that these two are corresponding. So now let's look at the queries. So let's look at it in a reverse order. So for I in range m minus 1. So this is the starting index, m minus 1. And then we are going to end before -1, that is index 0. The increment is -1. In other words, each time we are going to decrement the index by 1. And then let's first get the current type and the index and the value. That will be query at index I, right? And then let's check if type is 0. So this means that we want to change the corresponding rows, right? And then we also need to know if index not in thin rows. So if it's appearing in the with a larger index, the larger index value will dominate, right? So here, if not, so what we are going to do, we're going to increment the result. So we want to see how many values are changed, right? So this actually is nothing but n minus n thin. So here we are going to check columns, right? So like here, we're going to check, when we set the columns, we're going to check the rows, right? So this will be this, and then these zeros are changed to be the value, right? Then after we increment the result, so we're going to do this thin, let's see, thin rows. Let's add this index, and meanwhile, n thin rows, the number of thin rows is incremented by 1. So this is one case. Otherwise, if type is 1, so we're going to check columns. So we want to make sure IDX and not in thin columns, right? That's the role of the two sets playing. So then we're going to increment the result. This is actually in symmetry with this part. That will be, here we want to set our columns. So we are going to check the number of rows already settled by the queries after I, right? That is n minus n thin rows. So this number of zeros are changed to be value. So that's the increment for the result. And then we're going to do thin columns. So we're going to add the index. And also we're going to increment n thin columns by 1. Right. So then we can return the final result. So this is the final state of the result variable, right? So before we make further comments, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here another comment we want to point out is that so the queries can be very long, but overall the index for the rows and for the columns are 2 times n, right? So these are the n thin rows and n thin columns. So once we thin n rows and n columns distinct, right? So we can directly return. So we don't need to scan the previous queries. So in other words, when we look at this, when we enter this for loop, we can add a check. So we check this to this one. And thin rows, number of thin rows plus number of thin columns. So if this is 2 times n, so we just break, right? Then we just directly return the result. So this is plays as a early stopping condition. So now let's check this part. Yeah, it works okay. So, but this is not absolutely necessary. But if you add it here, it's okay. It depends on your preference. So with that said, basically that's about it for this specific problem. So thank you.